So my name's Caitlin Lovell. I'm the Division Manager for the Science, Fish, and Wildlife Program from the City of Portland's Bureau of Environmental Services. I have a really cool job. In my role, I actually get to take all the great science, a lot of the stuff that we've been hearing about, and actually turn it into policy for the city and affect projects on the ground. As the Bureau of Environmental Services, we are responsible for all the sewer, stormwater, and watersheds within the city. We're the lead agency in that regard. And in that role, we are also responsible for dealing with and responding to the Endangered Species Act, the Clean Water Act, the Safe Drinking Water Act, CERCLA, Superfund, the FEMA's National Flood Insurance Act, and our own asset management. Which pipe should we replace and which facility should we maintain on what time period? So with that context and with my role, I started to ask the question, is it worth doing these restoration projects that we do in the face of climate change? I was joining a growing chorus of people who asked this question, from funders to regulators to our decision makers. A lot of these folks were asking these questions even without climate change. Is it worth just doing restoration in an urban area, period? I was coming in with a slightly different tact on it. So I commissioned a study with ICF Jones and Stokes, a modeling analysis, with Chip McConaughey, who could not be here today, so he apologized. But we commissioned a study using ecosystem diagnosis and treatment to look at potential restoration projects and see how those changed with and without climate change. So I'm going to jump to the conclusion. We calculated between a 26% and 112% increase in our salmon and steelhead populations in the urban area, even with climate change, as a result of our restoration projects. So if Chip were here today, he would tell you don't believe those numbers. All models are wrong. Some models are useful, right? So this gives us a false sense of precision, but it provides a very useful analysis for us moving forward. And I'll just spend the next 10 minutes caveating all of these numbers. I do want to point out these pictures as we go forward. This is in Crystal Springs. Some of you who were on the tour on Wednesday were just a little upstream. The stream runs under the road here, and we're doing a culvert replacement project. To orient you guys, the projects that we analyzed were all in Johnson Creek. Portland sits at the critical confluence of the Willamette and the Columbia Rivers, the 19th and 4th largest rivers in the United States, respectively. And as a result, we have over 16 endangered species, listed endangered and threatened species, flowing through our city. Salmon, steelhead, eulachon, trout, sturgeon, and most recently proposed the streaked-horned lark, which is a ground nesting bird. We're averaging one species listing a year, and as far as we can tell, we have the most listed species of any city in the United States. So Johnson Creek flows into the Willamette River. It's our largest salmon-bearing stream in the city, and as such, it is a primary focus for us for salmon and steelhead recovery. There are many reasons why we do the projects that I'm about to talk about. As I mentioned, all these regulations that we have. So we're doing these projects for flood management, for water quality, for asset management. But every time that we're doing it, the end goal is making sure, in fact, our mission is to protect public health and the environment. And so we're always looking to make sure our projects are contributing to salmon and steelhead recovery where we can. But we have to do so in a way that uses our ratepayer dollars responsibly. So that's why we're asking these questions. So we analyzed these three projects. The type of projects that we looked at here were mostly floodplain off-channel habitats. East Lents, folks visited on Wednesday. It's a big floodplain project. Luther Road, we haven't constructed yet, but it's an off-channel project to protect our pipe. It's a pipe rehab project. And the confluence was done by the Watershed Council to add complexity to the stream. The other set of projects that we looked at in Crystal Springs are mostly access, cold water access, and some water quality improvements. This project, a lot of people visited on Wednesday as well. It's near and dear to my heart. It's my pet project. We only analyzed 4 of the projects. We actually have 9 in Crystal Springs. We're about to complete the last 2 next summer. So what is ecosystem diagnosis and treatment, or EDT? In short, it's an equilibrium model that looks at the carrying capacity of a stream. And the carrying capacity is determined through measured and surveyed habitat parameters that are specific to different species at different stages of their life history. And they look at the genetically determined habitat needs of those species that have been analyzed throughout the scientific literature. From there, it's pretty obvious. A coho needs are different than steelhead needs, and what they need at age 1 versus age 4 are going to be different. So this model takes all of that into account. It allows us to ask that and answer the question, what is this project going to do for salmon? So a particular stream or project is actually assessed using baseline data, existing data, and then we look at the project as it's designed, and it gets pretty empirical. We ask, we survey data, we have elevations, we have size of gravel. Those are some of the inputs into this model. And we ask, how do the habitat attributes measure up to the expected performance based on the species needs? Then the model will output pretty much how many fish can you expect at each life stage. And again, I want to caution you, the numbers are not absolute. And so when we get abundance numbers out of this, there's this big kind of asterisk to it that these are not the actual numbers that you should expect to see because of things like natural environmental variation and other non-habitat factors. So this is kind of, I'm not going to walk you through this at all, but this is one of the outputs where we have the different life stages, the different species. Red is a primary limiting factor, and then we have all the different habitat conditions, and we can run a project through and see which habitat condition are we having the biggest effect on, and how is it lining up with the primary limiting factors, so spawning, fry colonization, what have you. All right, I'm going to quickly move back off that slide. So Chip McConaughey, who's the primary author of the study, had very fortunately for us done his dissertation on Johnson Creek and had already established a baseline for coho in the year 2000. When we asked him to do this in 2009, we needed to update the model. We had done a lot of work, including this really awesome project, floodplain project called the Schweitzer Project. That used to be a hay field that was completely disconnected. The stream ran around that side, never touched the field at all. We have come in and clearly re-meandered the stream, and now it's full of beaver. It's way cool. And it floods all the time, which is great. So we needed to change our baseline. In addition, EDT as a model had evolved. And so instead of just having coho to look at, we wanted to add in Chinook and steelhead. By looking at all 3 species, we get a much more comprehensive look at the entire ecosystem needs, not just a particular species needs. So that was pretty important to us as well. So once we updated the baseline conditions, then we looked ahead 5 years and we said, okay, what are the projects that we have in the books that we can analyze with enough detail to see some results? And in these prior maps I showed you, we analyzed 7 different projects that we had planned in the next 5 years. And then for this study, we took it a step further. We had already done this analysis for Tryon Creek, and it was great, but we finally started to ask the question, what's climate change going to do to this? We asked a companion question, what's development going to do to this? I'm not going to talk about that, but it's pretty much the same approach and the same analysis. And then we wanted to know how that changed the outcome. So to look at how climate change affects this, we didn't have any downscaled models at all for Johnson Creek. So we took the regional models, I should say ICF took the regional models and looked at what the median temperature would be in the year 2040 and what the median temperature and precipitation would be. So, I mean, no surprise, right? Hotter, drier summers, warmer, wetter winters. That's kind of the theme. Well, then when you look at the parameters in EDT, what changes? So it's all stuff we've been hearing about. Temperature goes up, lower flows get lower, the wetted width increases at certain times of the year and decreases at other times of the year, higher high flows, more variability in the interannual flows, and greater bed scour. So those are the 6 parameters that they adjusted to reflect these climate change areas. And this is how it plays out. This is Foster Floodplain, the East Lents project. For those of you who were with us on Wednesday, we were standing right there in the middle of the red circle. The white, it was a rain on snow event, and with a major melt in 2009. The white represents the snow on the roof of houses. The brown represents the flooding. The blue is the river, or what should be the river's channel. And so when we analyze this as a baseline condition, clearly, the wetted width increased, and there's really crappy habitat in this development right here. But the project took away all of those houses, restored that floodplain, and so the post condition was a significantly different picture from a salmon's perspective. All right, so here are the results. Again, I'm going to channel Chip. Don't believe the numbers. They're all relative, and it helps us compare these projects with and without climate change, and actually the projects within themselves. So we're starting here, our baseline condition. Part of the reason we have such high percentage increases is because we're starting with such low baselines. Without climate change, we are expected to see increases from 123%, 52%, and 118% as a result of our restoration projects. When we add climate change, we see a reduction, but we don't see it completely undermine the benefits of the project. What I think we're able to do with this kind of relative comparison is get some insights into some very specific questions we have. For example, which species are going to be most affected by climate change in our system? Clearly, steelhead is looking like it's going to be pretty significantly impacted, whereas Chinook doesn't show that much of an impact. So for us, from a project design perspective, what EDT is helping us determine is what are the things that we have to be doing differently to bump this number up a little bit. So for that, we look at what are the primary limiting factors. For steelhead, things like cold water access, spawning habitat, and our projects are going to start prioritizing those elements to the extent that they can and they're appropriate. The fact that climate change reduces the value of this project but doesn't undermine the projects completely is pretty important. So the answer to the question, is it worth it to do these projects in the city, is a resounding yes. In all cases, there was a net benefit. The other couple of take-home points that I think are pretty important from using this in any model is that our projects were synergistic. So if we were to look at any one of these projects independently with this climate change lens, it is likely that it would not have produced the result. Climate change would have overwhelmed the project. And so given that, would we do the project? As decision makers, if you're looking at that saying, well, in the face of climate change by 2040, why bother? But climate change is, as you all know, a big problem over a long period of time, and so you need to look at your big solution over a long period of time, and don't analyze projects on an individual basis. Look at your entire strategy. I think that's also important too because it helps build diversity. As I mentioned, we had two different types of projects that we analyzed. The ones in Crystal Springs were access cold water projects. The other ones were more in-stream habitat complexity and floodplain. They produced different results. In our analysis, the Crystal Springs projects contributed much more significantly to that bump in benefits than the floodplain restoration projects. That's not to say that those aren't critically important, but we just need to understand where they fall in the spectrum, and that the diversity of all of these projects is what really gives you the power to overcome the impacts of climate change. Also, as I mentioned, because steelhead was the most impacted, we're going to be paying special attention to that. We'll prioritize projects like Crystal Springs, where we're opening up access to cold water, headwater projects. And then finally, I think it's a little bit buried in here, but I want to finish and wrap up with this thought. If we didn't do these projects, what this model shows us is that we'd likely be looking at extinction events in the city. And that is just an unacceptable outcome. our city council has told us we're going to be contributing to recovery. It's a moral position that they've taken, if anything. But I think as a society, and when we were talking about communicating the message, we're going to expect extinction events with climate change, but we're going to expect them on the edge of their range. In places like this where we know we can do something about it, where we have now empirical evidence that shows we can actually help contribute to the recovery of the species even in the face of climate change, and if we still choose to do nothing that results in an extinction event, we have a really poor story and a poor track record then for future generations. So, thank you.